Hello everyone, welcome back to the channel. Let's start paper 4 of AL2 chemistry or A-level chemistry, October-November 2025, variance 42. Let's start with the question number 1. Question number 1 belongs to group 2 elements, I believe. This means this question is going to be the most easiest one. Anyway, let's start the question. Magnesium nitrate and strontium nitrate both decompose when heated to form metal oxide and mixture of gases. And obviously, when we talk about mixture of gases, it has to be mixture of nitrogen dioxide and obviously oxygen. So examiner is looking for an equation for the thermal decomposition of magnesium nitrate. So equation is going to be written like this. Magnesium nitrate is decomposed on heating to give magnesium oxide, nitrogen dioxide, and oxygen gas. All right. So you can write this equation for 1 mole also. I've written for 2 moles. You can write this equation for 1 mole also. And that's going to be acceptable in the paper also. Okay. Next. Which magnesium nitrate or strontium nitrate decomposes at lower temperature? Lower temperature means easier decomposition. The examiner is looking for the explanation. So compound that decomposes at low temperature, obviously magnesium nitrate. Okay. But what's the reason behind this? Obviously, magnesium ions has a small ionic radius. So obviously it has high charge density and polarization. Consequently, magnesium ion can distort the electrons of nitrate ions easily. Hence, less energy is needed for decomposition. Therefore, decomposition occur at low temperature. Okay. Magnesium oxide and strontium oxide both react with dilute sulfuric acid because both of them or basic oxide. So let me write the equation. So this is magnesium oxide. When it is treated with sulfuric acid, it will turn to magnesium sulfate and water. Similarly, when strontium oxide is treated with sulfuric acid, it will turn to strontium sulfate and water. Now, examiner is saying that magnesium oxide forms a soluble salt, which means magnesium sulfate is soluble, and strontium oxide forms an insoluble salt, which means strontium sulfate is insoluble. So down the group, the solubility of group 2 sulfates decreases. That's what we have done in the class. So identify the products formed when magnesium oxide reacts with dilute sulfuric acid. So examiner is looking for the products. Examiner is looking for the products. That means I have to write both the products like magnesium sulfate and water. Explain why is more soluble than B. So first of all, let me remind you that magnesium ion has smaller ionic radius than strontium ion, which means magnesium ion has high charge density than strontium ion. If magnesium ion has high charge density, and we know that both lattice energy and hydration enthalpy depends on charge density, higher the charge density, higher the lattice energy and hydration enthalpy. So both lattice energy both lattice energy and hydration enthalpy increases. But since hydration enthalpy play a vital role here for solubility of sulfates, which means hydration enthalpy becomes more exothermic as compared to lattice energy. If hydration enthalpy becomes more exothermic than lattice energy, then it means the standard enthalpy change of solution becomes more exothermic. then lattice energy. Oh, then the standard enthalpy change of solution of strontium ion. Okay, so remember two things. First of all, solubility of sulfates and carbonates can be explained on the basis of two factors. The first one is lattice energy and the second one is hydration enthalpy. By the way, hydration and lattice both are exothermic process, and both of them depends on charge density. The higher the charge density, higher the lattice energy and higher the hydration enthalpy. But hydration has a significant role, which is why hydration enthalpy becomes more exothermic as compared to lattice, and therefore solution becomes exothermic. So remember this expression also. We have discussed this expression in the class. All right. This entire thing is endothermic. And this entire thing is exothermic. So if this value is greater, which means hydration becomes more exothermic, solution becomes more exothermic. And if solution becomes more exothermic, obviously solubility increases, which is why magnesium sulfate is more soluble than strontium sulfate. I hope it makes sense to you. That's the end of question number 1. Let's move on to the next question. Question number 2. Okay, let me read the question. Ethanol is basically an aldehyde, reacts with nitrogen dioxide. All right. The product of the first step of this reaction are a dash radical and a molecule of nitrous acid. So basically, when these two reactants react together, you will get a radical and nitrous acid in the product. So formation of radical always occurs because of the homolytic fission between carbon and hydrogen molecule, right? Oh yes. Oh yes, that's logical. So see, guys, this is the structure of ethanol. Okay. Now we have carbon-hydrogen bond here. So this bond undergoes homolytic fission. And because of that, when homolytic fission takes place, I'll get this radical. And hydrogen radical. NO2 has single unpaired electron. Nitrogen dioxide has nitrogen atom, which is the central atom. It has single unpaired electron. So it can combine with this hydrogen radical to give nitrous acid. And that is the whole mechanism behind this process, okay? So examiner is looking for the two words to complete the sentence. The reaction involves dash of the single covalent bond between hydrogen atom and carbon atom. So between carbon and hydrogen, there is a homolytic fission takes place. So I'm going to write homolytic fission here. Okay. Hydrogen atom mentioned in A1 forms a covalent bond with one of the oxygen atom of NO2 molecule. Okay. And NO2 molecule has a single unpaired electron on the nitrogen atom. That's what I've told you. That's a very, very powerful and an important statement. Okay, so draw a dot and cross diagram of NO2 molecule. Show outer shell electrons only. So technically, nitrogen belongs to group 15 of the periodic table, which is why it has 5 valence electrons, which are represented by cross 2, 3, 4, and this one is 5. Now we have 2 oxygen atoms, so I will write one oxygen atom here. Now oxygen has N1 oxygen atom here, obviously. Now oxygen has 6 valence electrons because it is found in group 16 of the periodic table, which are represented by dot. So these are the 6 valence electrons of oxygen. We have 6 valence electrons of oxygen on this also. So that's the dot and cross diagram of NO2 molecule. But in this dot and cross diagram, you have noticed one thing, that nitrogen and oxygen has a double bond, whereas nitrogen and oxygen has a dative bond also. Dative bond is also called coordinate covalent bond, and nitrogen has one single unpaired electron. That is the whole criteria. That is the whole thing. Okay. So that's the structure of NO2 molecule, but hydrogen radical combined with this oxygen to give HNO2. Okay. Now, in the remaining part of the question, examiner is looking for the dot and cross diagram of HNO2 molecule in which all electrons are paired. And we need to mention the dot and cross diagram. Oh my goodness. Okay. Nitrogen again has 5 valence electrons. So this is 1, this is 2, this is 3, this is 4, this is 5. All right. Now oxygen has 6 valence electrons. 1, 2, 3, 4, 5, and this one is 6. And hydrogen is represented by cross. Similarly, there is another oxygen atom which has 6 valence electrons. So this becomes 4 and this one is 6. So remember, in HNO2 molecule, oxygen and hydrogen has a single bond. Oxygen and nitrogen has a single bond also, but nitrogen and oxygen has a double bond also. So that's the structure of HNO2 molecule, and that's the structure of NO2, and that's the structure of HNO2. Okay, I hope it makes sense to you. Use valence shell electron pair repulsion theory to predict the bond angle of nitrogen atom in HNO2 molecule. So HNO2 has a structure like this. Now, according to my first year lecture, I mean A1 chemistry lecture, in order to find the hybridization, we need to consider double bond as a single bond. So around nitrogen, we have one single bond here and one single bond here. So technically, nitrogen has 5 valence electrons, 1, 2, 3, 4, and 5. So in the valence shell, we have 2 single bond around nitrogen atom and 1 lone pair. So total is going to be 3. We need to draw 3 lines to get the hybridization. The first line is always represented for s orbital, and the remaining 2 lines are represented for p orbital. So the hybridization is going to be sp2. According to A1 lecture, I've told you whenever we have 3 single bond and a 0 lone pair with sp2 hybridization, angle is going to be 120 degree. But since we have 1 lone pair, so according to first year lecture, whenever 1 lone pair increases, 2.5 degree angle decreases. So instead of writing 120 degree, I'm going to write 117.5 degree. Okay. So guys, I think you need to revise the bond angles also from A1 chemistry lectures. All right. Examiner can ask this sort of area also. Part B. The rate equation for the reaction between ethanol and NO2 is shown. The rate equation is given, and from this rate equation, I conclude that with respect to ethanol, it is first order, and with respect to NO2, it is also first order. So both of them has an overall order of second. Okay. Under certain conditions, when concentration of both ethanol and NO2 are 0.2 mole per dm cube, and the rate of reaction is given, calculate the value of the rate constant. Under this condition, give the units of K. So let me write the rate equation again. Rate equals to K concentration of ethanol and concentration of NO2. Let me plug in the values. The value of rate is 1.53 into 10 to the power minus 4 equals to K. Concentration of ethanol is 0.2 mole per dm3. Concentration of NO2 is also 0.2 mole per dm3. So the value of K is going to be, value of K is going to be 3.825 into 10 to the power minus 3. Okay, let me get the units also. By the way, rate as a unit of mole per dm cube per second. We need to find the value of unit of K. Now ethanol has a unit of mole per dm cube. NO2 has a unit of mole per dm cube. So when two units are multiplying together, we need to add the power. So it's going to be mole square dm minus 6. So K is basically mole per dm cube second inverse divided by mole squared dm minus 6. I'm going to cancel out these two units. So the unit is going to be 1 upon mole per dm cube. And this is second inverse, right? So the final unit is going to be mole inverse dm cube per second. And that's my unit. I hope it makes sense to you. I hope you get the point. Whew. Okay, let's move on to the next page. The reaction mixture described in B is monitored over a period of time. Predict whether the graph of concentration of NO2 against time shows a constant half-life. Explain your answer. In the previous years, when we use order with respect to specific reactant, we can, and if it is belong to first order, we normally say that we have a constant half-life. All right. So this NO2 has a first order reaction, which means it is a constant half-life. But since the overall order is second, so prediction is going to be not a constant half-life. Okay. Explanation, because overall order is second. And in second order reaction, we don't have constant half-life. Okay. In fact, in the second order reaction, the half-life or the successive half-life increases. All right. That's what we have done in the class. Ozone and NO2 also react together. The rate equation is given. And with respect to NO2 here is first order. Under certain conditions, the value of rate constant is given. The reaction has a constant half-life, which means it is first order. Okay. Calculate the half-life in seconds. So since it is a first order reaction and the half-life is basically equals to 0.693 upon K, 0.693 will remain as it is, and the value of K is given, which is 0.0848. So the half-life is going to be here 8.1 second. And that's my answer. Okay. That's easy. NO2 is present in the exhaust gases of cars. It can react with carbon monoxide on the surface of heterogeneous catalyst in the car's catalytic converter. By the way, heterogeneous catalyst in which reactants and catalyst have different physical state. Okay. And in heterogeneous catalyst, normally two processes are extremely important. The first one is adsorption, which normally takes place onto the surface of the catalyst. And the second one is desorption, in which product molecules will leave the active site from the surface of the catalyst. Okay. So these two processes are really, really important behind the whole mechanism. So describe the mode of action of this heterogeneous catalyst. Okay. So first of all, reactant molecules are adsorbed onto the surface of catalyst via active sites. And guys, active sites are the vacant d orbital of transition elements, if you remember. Second, due to which reactants forms a strong bond with the active sites, due to which internal covalent bonds start to break. So this lowers the activation energy also. After a series of reaction or after a series of steps, product is formed which will leave the surface from the surface of catalyst due to desorption. Okay. I hope it makes sense to you. I hope you get the point. Let's move on to the third question. Third question is related to ionic equilibria, and that's my favorite. Define conjugate acid and base pair. By the way, conjugate acid donates hydrogen, proton, and conjugate base accepts proton. So on the basis of that, I can write a pair which differs by proton is called conjugate acid base pairs. Okay, give the formulas of the conjugate acid and conjugate base of the hydrogen phosphate. By the way, this hydrogen phosphate has an amphoteric nature, which means it is acting as an acid, acting as a base also. For instance, like we have HPO4 2 minus. When it will accept proton, it will turn to H2PO4 negative. If it is a base, because it is accepting proton, obviously it's going to be conjugate acid. So conjugate acid of HPO4 2 minus is going to be H2PO4 negative. All right. Let's suppose HPO4 negative behaves as an acid and we treat it with alkali, it will turn to water and a phosphate ion. So if it is an acid, obviously it is going to be a conjugate base. So conjugate base of HPO4 2 minus is going to be phosphate ion. Okay. Next part, the Ka of propanic acid is this. So K, the value of K is given. The value of pH is also given of propanic acid. An examiner is looking for the concentration of propanic acid. I have given you the formula. pH equals to minus log under root concentration of acid into Ka. You can apply that formula and get the answer. Because it has 2 marks, so you need to show 2 steps, right? What I'm doing is, we know the value of pH. So by using this expression, I can find the value of concentration of hydrogen ion. So it's 3.6 equals to minus log concentration of hydrogen ion. So from here, the concentration of hydrogen ion is going to be 2.511 into 10 to the power minus 4 mole per dmq. Let me write down the acid dissociation expression, which is concentration of propanoate ion, concentration of hydrogen ion, and concentration of propanoic acid. Okay. We know the value of Ka is given, which is 1.35 into 10 to the power minus 5 equals to. Now, we know the concentration of hydrogen ion, and since both propanoate and hydrogen ion has 1:1 ratio in equation, which means the concentration of propanoate ion is also same. So what I'm doing is, I'm going to write 2.511 into 10 to the power minus 4. That's the concentration of propanoate ion because of 1:1 ratio. And that's the concentration of hydrogen ion divided by concentration of propanoic acid, which we need to calculate. So I firmly believe that the concentration is going to be how much? I think it's going to be 4.67 into 10 to the power minus 3 mole per dm. Let me calculate one more time. It's basically 2.5 exponent minus 4 into 2.5 exponent minus 4 divided by 1 point divided by 1.35 exponent minus 5. So 4.629 4.629 4.629. So let me write 4.629 into 10 to the power minus 3. Okay, that's the answer I'm getting on my calculator. Oh, that's the answer, guys. By the way, we have done one formula in the class. Let me show you that formula. pH equals to minus log under root Ka times concentration of acid. I mean, you can apply this formula to get the concentration of acid. So you will get the same answer from this expression also. So you can use this formula also. We have done that formula in the class. Okay. We have done both the concept. So it's totally up to you which formula suits you and easier for you. Oh, calculate the concentration of hydroxide ion in solution C. In order to get the concentration, first I need to find out the value of pOH. And for that, I'm going to use this expression. pH plus pOH equals to 14. pOH equals to 14 minus 3.6. Yeah, 3.60. So the pOH value is going to be how much? 10.4. Now from this pOH value, I can get the concentration of hydroxide ion. That's 10.4 equals to minus log under root hydroxide ion. So the concentration of hydroxide ion is going to be 3.98 into 10 to the power minus 11 mole per dm cube. Okay. So it's basically shift log minus 10.4. So 3.98 into 10 to the power minus 11. That's the answer. Okay. Calculate the concentration of a solution of hydrochloric acid, the same pH value as solution C. Well, that's easy. That's very, very easy. We have a pH value. Using this pH value, which is 3.6, I can get the concentration of hydrogen ion, which is the same value which we have calculated in B part 1. That's 2.511 into 10 to the power minus 4 mole per dm cube. Okay. We know that HCl is a strong acid, ionizes fully into its hydrogen ion and chloride ion. According to the equation, we have 1:1 ka ratio. So when we have 2.511 into 10 to the power minus 4 molar means mole per dm cube, then obviously we'll get the same concentration of HCl also. And that's basically 2.511 into 10 to the power minus 4 mole per dm cube. Okay. So that's the answer for concentration of hydrochloric acid. I hope it makes sense to you. Let's move on to the next page. Okay. Table 3.1 shows 3 possible values for the dissociation constant of dimethyl propanoic acid. Place a tick in the table 3.1 to show the correct value. Explain your answer. Okay. Okay, let me show you the structure first. This is CH3. This is CH3. This is CH3. This is CO, O, and H. By the way, specifically, I have discussed this area with you in extreme detail so that you can handle such sort of explanation. And this explanation has 3 marks. In the class, I have told you whenever electron donating alkyl groups are attached to any carboxylic acid, the acid strength always decreases. If acid strength always decreases, obviously the value of Ka becomes higher. Okay. So there's technically the value of, but why? What's going on basically when we attach electron donating alkyl groups to this? By the way, all alkyl groups has a positive inductive effect, and this positive inductive effect is represented by this. Okay. Now this carbon is extremely electron rich because of these three alkyl groups. So this carbon is extremely electron rich. If it is electron rich, it will donate its electron to this carbonyl carbon, and as a result, its partial positive charge neutralizes easily. On the basis of that charge neutralization, oxygen cannot pulls the electrons from hydrogen, and similarly, ionization of hydrogen from here is not easier. Since ionization of hydrogen is not going to easier, which is why its acid strength decreases. On the basis of that, the value of K is going to be the first one. Okay, predicted value or possible value, you can say that. In class, I've told you whenever acid strength increases, value of Ka increases, value of pKa decreases, and acid becomes stronger, right? So on the basis of that particular explanation statement, I've decided the value. So I'm gonna take in the first column. Okay. And I have to write the entire explanation also. My goodness. Okay. Electron donating alkyl groups has positive inductive effect. So electron pulling effect of carbonyl carbon becomes weaker. Due to which ionization ionization of hydrogen is not easier. Also, due to positive inductive effect, also also this positive inductive effect destabilizes the Ni. Okay, and you need to revise this particular entire concept again from my lecture so that you can have an idea what is mean by destabilizes the Ni. It's basically linked to resonance phenomena. Okay, and in that particular resonance phenomena, oxygen, the negative charge of oxygen atom is oscillating. So because of that positive inductive effect, resonance जो है वो नहीं होगी फिर trigger इतनी quickly. Okay. Oh, okay. Solution D is made by mixing 100 cm cube of 0.1 mole per dm cube propanoic acid and 100 cm cube 0.1 mole per dm cube NaCl. Okay. So what we have done here is that we have a beaker. In this beaker, we have solution D. Okay. And in this solution, we have two different substances. The first one is NaCl, which has same volume and concentration as propanoic acid. Okay. And obviously, this beaker also has propanoic acid, which has same concentration and volume, which is okay. That's solution D. Examiner is saying the pH of solution D is measured as a small amount of H2SO4 are added to it. Okay. Okay. Let me write this down again. Okay. See, guys, when we add H2SO4 in it, then there will be no reaction. Because propanoic acid is an acid, cannot react with sulfuric acid, which is also an acid. So these two acids cannot react together. And also NaCl cannot react with H2SO4 of this concentration, okay? H2SO4. NaCl can only react with H2SO4 when it is concentrated. All right, that's what we have done in A1, if you remember, in group 17 elements. So in the first place, with H2SO4, there will be no visible reaction, okay? But when we use let's suppose NaOH in it, then there will be a reaction, obviously. Again, this NaOH cannot react with NaCl, but this NaOH can react with propanoic acid. So when NaCl, let me show you the equation. When propanoic acid reacts with NaOH, it is going to be an acid-base reaction, and as a result, you will get sodium propanoate and water. So technically, it is your salt of carboxylic acid. And this is going to be your acid. Okay. So that's going to happen in the second scenario. Okay, that's basically the scenario of NaOH. So in both the scenario, H2SO4 cannot react and NaOH cannot react with NaCl, but propanoic acid can react with NaOH, not with H2SO4. Let me read the question again. That's a very, for 1 mark, that's a lot of explanation and that's a lot of requirement. Okay, let me read the question. Solution D only acts as a buffer solution when one of these solution is added to it. Complete the sentence and write an equation for the reaction that occurs. Solution D acts as a buffer when sodium hydroxide is added to it. Buffer solution. For a buffer solution, you need acid plus salt of weak acid. That is the basic requirement of buffer solution. Okay. So technically, we have weak acid, okay, and salt of weak acid. Both of them exist in the beaker, so it acts as a buffer solution. So let me write down this equation here. Okay. Complete the sentence and explain why solution D does not act as a buffer when other solution is added. Solution D does not act as a buffer when sulfuric acid is added to it. Explanation. Since both are acids, they cannot react together. So there will be no salt of carboxylic acid. And salt of carboxylic acid is also called conjugate base. So you can write there will be no conjugate base, or there will be, or absence of conjugate base. Okay. Oh, it has not finished. That's a very, very huge question. Okay. Let's start with this part D. Magnesium 2 hydroxide is only slightly soluble in water. If it is partially soluble in water, let me write the equation first. It ionizes slowly and reversibly into its magnesium 2 ions and hydroxide ions. Okay. The solubility of magnesium hydroxide is given in gram per dm cube, which means, first of all, I need to take out the MR of magnesium hydroxide. So the MR of magnesium hydroxide is basically 88.4. All right. So to convert gram per dm cube into mole per dm cube, we need an MR of magnesium 2 hydroxide. And from these two values, I can find the concentration of magnesium hydroxide. So gram per dm cube is 3.28 into 10 to the power minus 3 equals to mole per dm cube into MR. MR is 88.4. When you divide the value, then you will get the concentration of magnesium 2 hydroxide. And the concentration of magnesium 2 hydroxide is going to be 3.28 into 10 to the power minus 3 divided by 88.4. So the concentration is going to be how much? 3.689 into 10 to the power minus 5 mole per dm cube. Okay. By the way, solubility and concentration is the same thing. So concentration in gram per dm cube is given, and concentration in mole per dm cube we need to find out. So the concentration of Manganese 2 hydroxide is 3.69 or 689 into 10 to the power minus 5. Okay. Oh, write an expression for the KSP. So KSP equals to concentration of manganese 2 ions and concentration of hydroxide ions. Since we have 2 moles in the equation, so we need to put 2 here as power. Okay. Unit, that's mole per dm cube, into that's mole per dm cube, and we have to place a square on it. So it's going to be mole cube dm minus 9. So yeah, mole cube dm minus 9 is going to be the unit for this. Use your answer to D1 and D2 to calculate the value of the KSP. Okay, let me write this equation again here. Okay, we know that manganese 2 hydroxide and manganese 2 ions has 1:1 ratio. So if we have 3.689 into 10 to the power minus 5 mole per dm cube concentration, obviously it will be the same concentration for manganese 2 ions also. Which is 3.689 into 10 to the power minus 5. And obviously, these two substances have 1:2 ka ratio. So obviously, the concentration of hydroxide should be doubled. So it's 3.689 into 10 to the power minus 5 into 2. So the value of hydroxide ion is going to be 7.378 into 10 to the power minus 5 mole per dm. Okay, let me plug in the value in this expression. So it's basically KSP equals to concentration of manganese ions, which is 3.689 into 10 to the power minus 5, and concentration of hydroxide ion, which is 7.378 into 10 to the power minus 5, and there is a square on it also. So the value is going to be 2 into 10 to the power minus 13. So the KSP value is 2 into 10 to the power minus 13. So that's the end of question number 3. That's a huge question, guys. Very, very huge. Let's move on to the next question. That is question number 4. Define enthalpy change of atomization. That's an easy definition. And this definition we have done in A1. Atomization is always endothermic. Remember that. So definition is going to be energy required when 1 mole of gaseous atom is formed from its elements in their standard states. Define first electron affinity. By the way, first electron affinity is exothermic, while second and third both are endothermic. So on the basis of that, energy released when 1 mole of an electron is absorbed in 1 mole of neutral gaseous atom. Oh, I forgot to write mole. In 1 mole of neutral gaseous atom. Okay. Explain why first electron affinity of chlorine is more exothermic than the first electron affinity of iodine. When chlorine has a smaller atomic size, while iodine has a bigger atomic size. So my first point here is chlorine has a smaller atomic size or atomic radius, you can write that. So it has a strong nucleus to valence electron attraction. So gain of electron is easier. All right. While iodine has larger atomic radius. So it has weak nucleus to valence electron attraction. So gain of electron is not easier. Okay. In the next part, examiner is looking for the enthalpy change of atomization of chlorine. And the first electron affinity of chlorine is given. And the enthalpy change for the reaction is also given. And this enthalpy change, we have two values, two different processes we have in this equation. The first one is atomization and the second one is electron affinity. Okay. So this equation has atomization and electron affinity both. And we need to find out the value of atomization. So let me make the cycle here. In fact, Hess's law cycle. This is chlorine gas gaining 2 electron, converting into chloride ions gas. Okay. And the value for this equation is minus 486 kilojoules per mole. Now this equation has two steps. First is atomization and then electron affinity. So let me make a Hess's law cycle. So in the first step, I'm going to convert chlorine molecule in 1 mole of gaseous chlorine atom, and that's basically atomization. Okay. Oh, my bad. My bad. It's not a mistake, but yeah, makes sense now. So I'm gonna write 1 mole of gaseous chlorine atom, and obviously it's going to be atomization. Okay. Now this gaseous chlorine atom gain 1 mole of electron and will turn to 1 mole of gaseous chloride ion. And this is going to be first electron affinity, which is minus 364. Okay. So if it is 1 mole, obviously it has to be 1 mole. To get 1 mole ki value, I need to use half here, half here. Okay. So technically it is a one-step reaction, and it is more than one-step reaction. Total amount of energy remains same. So that's root 1, that's root 2, and that's basically Hess's law. So I'm going to apply Hess's law cycle. This is delta H R equals to delta H1 plus delta H2. Delta HR is minus 486 divided by 2. Delta H1 is atomization, which we need to find out, plus delta H2 value is given, which is minus 364. So ये हो जाएगा आपके पास minus 486 divided by 2 is going to be minus 243 equals to delta HA minus 364. So delta HA is basically 364 minus 243. So it's basically plus 121 kilojoules per mole. All right. So the value of atomization of chlorine is plus 121 kilojoules per mole. And atomization is always endothermic. So we need to put 2 positive sign here also. Okay. So that's the end of question number, I believe, 4. And 4 is very, very easy. Let's talk about question number 5. But transition element, my favorite part of the A-level chemistry. Cobalt is a transition element which forms compounds containing cobalt 2 ions and cobalt 3 ions. Transition element has a very, very typical sort of property, and that property is basically they will show variable oxidation state, and so cobalt shows variable oxidation state also. It exists in cobalt 2 ions and cobalt 3 ions. Cobalt 2 sulfate dissolves in water to form a solution containing this complex ion. That's pretty much okay. Complete the electronic configuration of cobalt 2 ions and cobalt 3 ions. By the way, cobalt has an atomic number of 27, and its electronic configuration is argon, 3D, and 4s. Electron fill first in 4s and then 3D, so it's going to be 3d7. Now, to make cobalt 2 ions, obviously 2 electrons are removed from the 4s orbital, so the configuration is going to be argon 3d7. When we talk about cobalt 3 ions, which means 3 electrons are lost, so 2 electrons are lost from the 4s orbital and 1 electron is removed from the 3d orbital, so the 3d contains 6. Okay, explain why transition element can form complex ions. Because energetically vacant orbitals, my goodness, vacant orbitals are available for bonding. Okay. And these vacant orbitals are S, P, and D, because the hybridization for some was sp3 and for some is sp3d2. If you remember, we have done that in the class. Okay. 1 mark का पार्ट है तो आप vacant d orbital भी लिख सकते हो, कोई इशू नहीं है. You can write vacant d orbital also. instead of S and P शो करने की जरूरत नहीं है. And excess of concentrated hydrochloric acid is added to this. When we add concentrated hydrochloric acid, then there will be a ligand substitution reaction which is reversible, and you will get COCl4 2 minus plus 6H2O. We have done that this equation in the class. Describe the color change, observe, and the state of the cobalt containing product. So this is iron. The medium needs to be aqueous. So the state is basically aqueous. The color changes from pink to blue. Cobalt 2 ion has a pink color, and with COCl4 2 minus, it will turn into blue. Okay. Write an equation for the reaction. Oh, I need to write this equation again. Okay, no, not an issue. Reversible reaction है. Name the type of reaction. Ligand substitution reaction, also called ligand exchange reaction. Write an equation for the reaction that occurs when an excess of NaOH is added to a solution of this. We have done this equation in the class also. Let me remind you. This is aqueous cobalt 2 ions. And when we add a small amount of hydroxide, it undergoes an acid-base reaction, which is also called precipitation reaction, and will turn to this complex or will turn to this product. Okay. In class, I've told you that you can write this product in this way also. This way. Cobalt 2 hydroxide dot 4H2O. Okay. That's an alternative way of writing this complex. Okay. So examiner is looking for the equation. So I'm going to write this one again. Now put it here. Okay. I hope it makes sense to you. That's an easy thing. Oh, now there is a tricky part coming. Cobalt metals can be oxidized by acidified potassium dichromate 6. The relevant half equations and their E0 values are shown. All right. Cobalt metal is basically a reducing agent. This is an oxidizing agent, which means there will be a redox reaction between them. All right. Now, cobalt 2 ions has a negative SCP value, and dichromate 6 ions has a positive SCP value, which means this is going to be the positive half cell, this is going to be the negative half cell, this is going to be the positive terminal, this is going to be the negative terminal. Anyway, let's read the question again. The cobalt ion half cell electrode is constructed in which concentration of cobalt ion is 0.02 mole per dm cube at 298 Kelvin. By the way, this concentration is not 1 mole per dm cube, which means it is going to be the non-standard condition. And when we use non-standard condition, normally we use Nernst equation to get the E value for this half cell is minus 0.33. So the value of half cell is given. We need to show how could we determine this value. Okay. So I've given you Nernst equation in the class. That was E equals to E naught minus 0.059 upon N. N is basically the number of electrons log concentration of product, and product has cobalt metal, and metal is always solid. For all solid substances, we need to consider 1. If you remember the information, for all solid substances, concentration has to be 1. That's called unit activity, okay, over concentration of cobalt ions. Let me plug in the value. The E naught value is given, which is minus 0.28 minus 0.059 divided by n. N is number of electrons. Number of electrons is 2 log 1 upon concentration of cobalt 2 ion is given, which is 0.02. So the value of E from this calculation is going to be how much? Minus 0.33. Okay. Volt. Okay. Now, in the next part of the question is an electrochemical cell. A cell which converts chemical energy into electrical energy is called electrochemical cell. Is constructed using cobalt ion electrode described in B part 1 and dichromate 6 ions electrode in which all conditions are standard. Calculate the value of E cell. To get the E cell value, I'm going to use E right minus E left formula. E right means reduction potential or the potential value with a more positive SP value. So I'm going to write plus 1.33 volt. Yeah. And E naught left is basically minus 0.33 volt because we need to use this value as per examiner instruction. So the value is going to be 1.66 volt. Okay. A current is drawn in the electrochemical cell described in B part 2. Write an equation for the reaction taking place in the cell. I've told you in the class that when we have more positive SEV value, we need to consider this equation as it is in reduction form. All right. So I'm going to write this equation as it is. We have a very limited space, guys. Let me write it down. This is Cr2O72 negative plus 14 hydrogen ion plus 6 electron, reversible sign, 2 chromium 3 plus and plus 7H2. Okay. So that's the reduction equation. Since this half cell has a negative SEB value, which means we need to flip this equation in order to write in an oxidation form. So to get the equation in an oxidation form, I need to flip the equation like this. And we know that to cancel the electron, we need to multiply this equation by 3. As soon as the number of electrons are balanced, they will cancel out with each other. Now I'm going to write the product side and the reactant side, which is going to be Cr2O72 negative plus 14 hydrogen ion plus 3 moles of cobalt, 3 moles of cobalt 2 ions plus chromium 3 plus as it is and plus 7H2. So that's the equation examiner was looking for. Okay. I hope it makes sense to you. Complete the sentence to identify the negative electrode. Obviously, cobalt half cell has a negative value, so it has a negative electrode, and electrons always flows from negative half cell to positive half cell in the external circuit. So electron usually flow from cobalt half cell to dichromate and chromium half cell. Okay. A molten cobalt 2 salt is electrolyte using this much, so that's the current. This is I. This is mass of cobalt metal. Forms at cathode. At cathode reduction takes place. That means cobalt 2 ions will gain electron and convert it into cobalt metal. So I'm going to use this equation for this calculation, okay? Calculate the time in minutes. Answer basically given in three significant figures. So first of all, we have a value of mass of cobalt. So to get from this value of mass, I'm going to write oh my goodness. So first of all, we need to find out the moles of cobalt by using this mass. 0.547 divided by the AR of cobalt is 58.9. It's given in the periodic table. You can use that, okay? मुझे याद है इसलिए मैंने लिख दिया. So the moles is going to be 9.28 into 10 to the power minus 3 moles. Okay. Let me use the equation. This is cobalt 2 ions, 2 electrons, reversible sign, cobalt. According to the equation, we have 2 moles, and according to the equation, we have 1 mole of cobalt. When we have 9.28 into 10 to the power minus 3 moles of cobalt, so the moles of electrons would be 0.01856 moles, okay? We know the formula that moles of electrons equals to charge over Faraday constant. We know the value of Faraday constant. We know the moles of electrons. I believe I can get the value of charge. Charge is represented by this. So it's basically F. Moles of electrons is 0.01856 into Faraday constant. The value is given in the constants table at the end of this paper. वैसे बच्चों को याद होती है 96500 is the value. So it's going to be how much? 1791.042 coulombs. That's your charge. We know the formula. Charge equals to current into time. So I know the current, I know the charge. I can get the value of time from here. So that's 1791.042 divided by current, and current is 0.5 ampere. So time is going to be how much? Let me calculate. 1791.042 divided by 0.5. So it's 3582.048 seconds. Okay, I need to find out the value in minutes, so I'm going to divide this value by 60 because 1 minute has 60 seconds, so value is going to be 59.7. So in three significant figures, it's going to be 59.7. मेरे पास है 7014. So for three significant figures, I'm going to write 59.7 minutes. Okay, so that's question number 5. So we have done 5 questions so far. Let's start with the 6th one. Nickel forms complexes. That's another typical property of transition elements. They usually form complex ions or complex compounds. Give the formula and charge of the tetrahedral complex. When we say tetrahedral complex, which means the coordination number needs to be 4. And coordination number is also called fold number. So it must be 4, which means 4 ligands needs to be attached with the transition metal ion. And in this case, nickel is the transition metal ion. So 4 monodentate, 4 ligands needs to attach with nickel atom. And the ligand is basically the carbon monoxide, which is a neutral ligand, by the way. Oh, the carbon monoxide is a monodentate ligand and it is a neutral ligand. I mean to say carbon monoxide has no charge. So the formula and charge formula is going to be square bracket, that is coordination sphere. Nickel is a transition element, bracket, small bracket. We need to write carbon monoxide and we need to put 4 here. Since this is neutral ligand, it doesn't have any charge, and nickel has a 2 plus ion, 2 plus charge, so I'm going to write 2 plus here. Okay. Nickel has an oxidation state of 2 plus. So if it is neutral ligand, it has no charge, which means I need to put 2 plus here so that it shows the oxidation state of this nickel ion. Okay. All right. Okay. Now the next part is give the formula and charge of the octahedral complex formed by nickel 2 ions. So when we say octahedral, which means its fold number is 6. Matlab 6 dative bonds are formed between nickel ion and ligand. And this time the ligand is ethane dioate ion. I've told you in the class, ethane dioate ion has a formula C2O4 2 negative. So for octahedral geometry, I must say that ethane dioate ion is C2O4. It should be 3 because if one bidentate ligand forms 2 dative bonds, so when we have 3 bidentate ligands, it forms 6 dative bonds. And when it forms 6 dative bonds, so obviously the coordination number is going to be 6, and that's going to be the octahedral geometry. Okay, so what sort of charge should we put here? What we need to put here is basically, see, nickel, let's suppose is X. C2O4 is ethane diotide. It has -2 charge. We have 3 ethane diode ion, so it has to be into 3 equals to this much. Now X equals to this much plus 6. Now nickel has an oxidation state of 2 plus. So to get the 2 plus oxidation state, the charge needs to be -4, so that I'll get the +2 oxidation state of nickel 2 ion. Okay, so charge has to be -4. So the formula is going to be like this. And by the way, you can write this formula in this way also. And by the way, you can write this formula in this way also. Okay. So these are the multiple possibilities to write such formula. Identify which complex E or F exists as a mixture of 2 stereoisomers. Stereoisomers could be optical or geometrical. Since we have 3 bidentate ligands, which means it's going to be optical isomerism. So type of stereoisomerism, optical, and the complex which exists as a mixture of 2 stereoisomers, F, because whenever 3 bidentate ligands are involved, there has to be an optical isomerism in which we'll get the mirror images of each mirror images. Okay, that's what we have done in the class. Okay, cadmium forms complexes with methylamine and 1,2-diaminoethane, The value of stability constant for these complex ions are given in table 6.1. Explain by reference to its structure why CH3NH2 acts as a monodentate ligand. Monodentate ligand means donate one lone pair. Okay, so it donates one lone pair because nitrogen, because CH3NH2 has only one lone pair. Some cadmium aqueous ion is added. By the way, the formula of aqueous cadmium ion is going to be like this. H2O taken 6 and this is 2 plus is added to a solution containing equal concentration of this and En. Okay. Predict which of two complexes in table 6.1 forms at a higher concentration. Explain your answer. The higher the value of stability constant, the higher the concentration is. So I believe En and cadmium. So it's basically cadmium, ethylene diamine, 2 plus, because its value of stability constant is greater. So its concentration is higher. Okay. We need to write the stability constant of this complex ion. So first of all, let me write the equation. This is cadmium, H2O, taken 6, 2 plus 4 aminomethane, ligand substitution reaction takes place, and as a result, is going to be, that's going to be the product. Okay. So I have to write stability constant expression with respect to this equation. So K step equals to concentration of product, and the product is this complex. So this is going to be cadmium, CH3, NH2, taken 4. Charge has to be inside the bracket, so it's 2 plus and then bracket close. Okay. Over concentration of reactant. So these are the reactants. I'm going to write both of them. So it's basically cadmium, water, taken 6. Charge has to be inside the bracket. This is CH3NH2. Since we have 4 moles, so number of moles has to be in the power. So I'm going to write 4 here. Okay. And in stability constant expression, I'm going to ignore water. Okay. So that's the end of this question number 6, I believe. Yeah. Let's move on. Question number 7. Oh my goodness. P, Q, R, S, T, U, and V are the 7 structural isomers with molecular formula that have a carbonyl group. Now, either it could be aldehyde or ketone. So we have aldehydes and ketones. Only one of these 7 compounds have stereoisomers. Okay. When we talk about stereoisomers, basically we are looking either geometrical or optical. Geometrical isomerism always exists in alkenes. Since there is no alkene, so I believe geometrical is not going to be possible here in this scenario. So obviously I'm gonna go for optical isomers. Okay, and for optical isomerism I'll get the chiral carbon atom. There is no chiral carbon atom in this. There is no chiral carbon atom in this. There is no chiral carbon atom in this. um, there is no chiral carbon atom in this. There is no chiral carbon atom in this. There is no chiral carbon atom in this. There is a chiral carbon atom in this, and this is going to be the chiral carbon atom. Okay, so examiner is looking for the 3-dimensional diagram, 3D diagram for the 2 stereoisomers of this compound. So let me write. This is carbon. Okay. Oh. And to get the mirror image, okay, I'm going to put CH2 and CH3 here. I'm going to write CHO here. I'm going to write hydrogen, and this is going to be CH3. So it's going to be CH2, CH3. It is going to be CHO. This is H, and this is going to be CH3. Okay. So these are the mirror images of each other. आप इस ग्रुप को ऐसे भी लिख सकते हो, CH3, CH2. Okay, both are acceptable, not an issue at all. कौन सा ग्रुप किस जगह पर अप्लाई करना है? A2 केमिस्ट्री में वो और A1 केमिस्ट्री में रूल्स इंप्लीमेंट नहीं होते, so it's your choice. कोई भी ग्रुप किसी भी जगह पर लगा सकते हैं आप. Okay. Next is PQRST, U and V are treated separately with alkaline aqueous iodine. That's important. Alkaline aqueous iodine give you a positive result when aldehyde and ketone has this group. So let me search which compound has this group. Okay. It doesn't have CH3CO group. It doesn't have CH3CO group. It does have CH3CHCO group. It does not have CH3CO group, but it does have a CH3CO group, C. Okay. And obviously these two compounds doesn't have CH3CO group. Okay. So V and T both shows iodoform test. What? V and T. Okay. This is V and this is T. Describe the observation. When one of the compound you have identified in B1 is treated with alkaline aqueous iodine, and give the structural formulae of the 2 carbon containing products of this reaction. So observation, whenever iodoform test will observe yellow precipitates. Now either I will use V or T, so I'm gonna go for T. I'm gonna use T. दोनों से कर सकते हो, T सही है, ज़्यादा convenient है T. So T is basically CH3, CH2, CH2, So this is going to be your C double bond O, and this is going to be your CH3. So when you treat it, this is T by the way, when you treat it with alkaline aqueous iodine, CH3 with a blue pen will turn to CHI3, that will give you the yellow precipitates, plus CH3, CH2, CH2 will remain as it is. That carbonyl group will remain as it is. And I'm gonna put OH here. Since the medium is alkaline, then there will be an acid-base reaction, and as a result, you will get a salt. Okay. So two carbon-containing products. The first one is CHI3, and the second one is salt, CH3, CH2, COO negative. Okay. These are the two carbon-containing products. Oh, my bad. I forgot to write one more CH2. Okay. Okay. Let's move on to the next page. PQSV proton and NMR spectra of these compounds are compared. Identify only one compound that gives a spectrum with two singlets and no other peaks. Examiner is looking for the two singlets and no other peaks. Two singlets in the proton and NMR spectrum. Three, four, five. We have 5 peaks here according to n+1 rule, so it's not going to be the correct option. We have 1, 2, 3 peaks. We have 3 peaks from here. You need to apply n+1 rule on each and every compound. So I'm applying n+1 rule in my mind, and I'm getting the number of peaks quickly. Okay. So this will give you singlet. This will give you singlet. This will give you singlet. This will give you another peak. 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 So 1, 2, 3, 4, 5 peaks from here. Let's suppose this will give you triplet. This will give you 3 plus 1, 4 quantate. And this will give you duplet. This will give you 2 plus 1, 3. This will give you quadrate. This will give you duplet also. Okay. First peak, second peak, third peak, fourth peak. So we have 4 peaks here. 1, 2, 3, and 4. We have 4 peaks here also. 1, 2, 3, 4. We have 4 peaks also. So I believe S is the right answer because it has only 2 peaks. This will give you first peak, and these 3 alkyl group give you second peak. This carbon will not give you any peak because it doesn't have any hydrogen atom. So it's not gonna sense the neighboring carbon atom. All right. So it's not gonna sense the hydrogen of neighboring carbon atom. So that will give you 2 peaks. So S is going to be the right answer. Let me show you why S. Why? Okay. Let me show you. This is CH3, carbon, CH3, and this one is CH3, and this one is COH. So if you apply n+1 rule, so it's going to be 0 plus 1, you will get 1. That means you will get singlet from this. As no hydrogen atom is present with this carbon, so this carbon is not going to sense the hydrogen of neighboring carbon atom. So this carbon atom will not give you a peak. So I'm not going to use this carbon atom. Okay. Now, on the other hand, these 9 hydrogen atoms have same chemical environment because ये 9 hydrogen atoms same distance के साथ attach हैं. Now these 9 hydrogen atoms has a neighbor carbon which doesn't have any hydrogen, so it's going to be one. That's going to be singlet. Okay. So these are the two singlet peaks. Okay. So these 9 hydrogen atoms has a neighboring carbon which doesn't have any hydrogen atoms. So I'm going to write here 0. 0 plus 1 is going to be 1. That's singlet. So you are getting only 2 singlets from this compound. I hope it makes sense to you. And that's how you need to apply n plus 1 rule on each and every compound here. Okay. Now table 7.1 shows a spectrum obtained from one of the compounds. Okay. So we have triplet, we have quadruplet. Identify the compound that gives this spectrum. Oh, again, that's very, very tough. Let me erase this. Okay. Which compound gives you triplet and quadruplet? Only triplet and quadruplet. So we have triplet, we have quadruplet, we have sextet from here. So it's not gonna possible. My goodness, let me read one by one. CH3, CH2, 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 and this is going to be COH. Okay. When I'll apply n plus 1 rule, so this will give you triplet. This will give you quadruplet. This will give you quintet. So we are getting 2 triplets, whereas we have only 1 triplet here, which means P is not going to be the actual compound. Let's talk about S. We need 1 triplet and 1 quadruplet, only 2 chemical environments. Okay. So this is going to be singlet. So there is no singlet in this spectrum, which means it is also incorrect. Now let's talk about this one. CH3, CH, CH3, CO, CH3. Now this CH3 will give you singlet, and there is no singlet in this spectrum, so it's going to get incorrect again. My goodness. Let's talk about this one. CH3, CH2, CH, CH3, and this one is COH. So this will give you doublet, and there is no doublet in this spectrum, which means Q is also incorrect. Let's talk about T. CH3, CH2, CH2, CO, and this CH3. Now this will give you singlet, okay? And there is no singlet in the spectrum, which means T is also incorrect. Oh my goodness. And obviously R, CH3, CH, CH3, CH2, and this COH. So this will give you triplet, and this will give you 1 plus 1, 2 hydrogen. This will give you again triplet. So we have 2 triplets, and this will give you how much? 3 plus 3 is 6, 6 plus 2 8, 8 plus 1 9. So this will give you multiplet. Okay, so there is no multiplet in this spectrum, which means R is also incorrect. Now only U is left. Let me give you the example. This is CH3, this is CH2, this is CO, this is CH2, and this is CH3. Okay, now see, both these 6 hydrogens have same chemical environment because these 6 hydrogens are attached with the same distance with respect to this carbonyl group, okay? Now these 6 hydrogens have 2 neighboring hydrogen atoms. So I'm going to apply n+1 rule here. So 2 plus 1 is going to be 3. So it's going to be triplet. So 6 hydrogens give you triplet. On the other hand, these 4 hydrogen atoms have same chemical environment because they are attached with the same distance with respect to carbonyl group. Now 4 hydrogen atoms, we need to apply n+1 rule on these hydrogen atoms. See, we have 3 neighboring hydrogen atoms, so it's going to be 4, it's going to be quadrate. So technically, we have only 2 chemical environment in this compound. One is triplet and one is quadrate, and that reflects the same sort of a spectrum, okay? Now triplet has the lowest value of chemical shift, and quadrate has larger value of chemical shift, okay? Because quadrate is attached closely with the functional group, whereas triplet is away from the functional group, which is why functional group has lower impact on this, which is why it has the lowest value of chemical shift. So right answer is going to be U. That's tough, guys. That's tough. Okay. Name the splitting pattern of the peak at 1.1. Since it has the lowest value of chemical shift, which means examiner is looking for the triplet. So name of the splitting pattern is triplet. Why we are getting the triplet? Because we have 2 hydrogen atoms in the neighbor carbon. In the neighbor carbon or in the adjacent carbon? Identify the substance that gives a small peak at 0 delta. By the way, this peak shows the TMS tetramethylsilane, and that tetramethylsilane is used as an internal reference solution. Okay. Next is the C13 NMR spectra is given and state the number of peaks in the spectrum of each compound. So in this scenario, we need to consider carbon atom. So I will consider this carbon, this carbon, this carbon, and these 2 carbon atoms have the same chemical environment. So technically we have 4 peaks. Now in the next one, we have first carbon. I'm going to use this one, and these 3 carbon atoms have same chemical environment. So I'm going to write 3 here. Next is first carbon, second carbon, third carbon, fourth carbon, and this one is fifth carbon. So we have 5 peaks here. Really? Okay. Now look, both these 2 carbon have same chemical environment because they are attached with the same distance with respect to carbonyl group. Now these 2 carbon atoms have same chemical environment also because they are basically attached with the same distance of carbonyl group, and this carbon has another chemical environment. So technically this compound has only 3 chemical environment. Okay, so that's the end of this question. Let's move on to the next one. Question number 8. Asparagine and aspartic acid both are naturally occurring amino acid. Amino acid is a class of compound which contain both amino group, that is NH2, and carboxylic acid group, which is COH group. Their structures and isoelectric points are shown. Define isoelectric point. A point at which no net electrical charge exists. Or you can write that amino acid exists in zwitterionic form. Both are acceptable, okay? Draw the structure of asparagine and aspartic acid at pH 2. So this pH, this is the pH of buffer solution. Okay. And I've told you in the class that the pH of buffer is lower than the pH of isoelectric point then NH2 undergoes protonation. Protonation means reaction with hydrogen ion. That indicates this NH2 will accept proton, this NH2 will accept proton, this NH2 not going to accept this proton because this NH2 is not amide. This is basically an amide functional group, and amides are neutral. They cannot act as an acid or base, okay? So asparagine is basically like this. This is CWH. This is CH. This NH2 will accept proton, and obviously it will turn to NH3 plus. This CH2 will remain as it is, and this amide functional group will remain as it is because amide is neutral, cannot react with acid or alkali, okay? Now this NH2 will accept proton, so aspartic acid has to be written like this: CWH, CH, NH2 will accept the proton, will turn to NH3 plus. This CH2 will remain as it is, and this is COOH, okay? My goodness, that's a lot of information. Asparagine and aspartic acid are treated separately with excess of lithium aluminum hydride. Draw the structure of the organic product of these reactions. See, lithium aluminum hydride is a reducing agent. And to be more specific, stronger reducing agent. So when we use a stronger reducing agent, obviously this carboxylic acid will turn to primary alcohol, and this amide will turn to primary amine, which is CH2NH2. Okay. So first, let me write the structure of asparagine. CH2OH. So this is CH2OH, and CWH is converting into CH2OH. Then CH will remain as it is. This NH2 will remain as it is. This CH2 will remain as it is. Next word is CONH2. That CONH2 will turn to CH2NH2 according to my lecture. Okay, that's primary amine. Let's talk about aspartic acid. Now, aspartic acid has CWH. It will turn to CWH. It will also turn to CWH. So both these groups will turn to primary alcohol. Okay. Well, rest of the molecule will remain as it is. So basically, this is CH2OH, CH, NH2, CH2, and this CWH will turn to primary alcohol. Okay, I hope it makes sense to you. Yeah, that's right. That's the answer, guys. I hope it makes sense to you. Okay. Propane dioic acid is treated with an excess of thionyl chloride, SOCl2. Then we'll get the product. Write an equation for this reaction. See, guys, we have two carboxylic functional group. So for two carboxylic functional group, I'm going to use 2 moles of thionyl chloride, okay? So this is CWH, this is CH2, this is CWH. I'm using 2 moles of thionyl chloride. So I'll get 2 moles of sulfur dioxide. I'll get 2 moles of HCl. And obviously this will give you the misty fumes. and the product, and the structure of product is already given here. So I'm going to write this structure like this: COCl, then CH2, and then COCl. Okay. Let me remind you one thing. हाइड्रोजन यहां से, क्लोरीन यहां से मिलकर बनाएंगे HCl. हाइड्रोजन यहां से, बल्कि इस तरह से देख लो, 2 hydrogen from this and 2 chloride combine together to give 2 HCl. Now 2 SO and 2 O combine together to give 2 SO2, and then chlorine attach हो जाएगा OH की जगह पे. सही है. Propane dioyl chloride reacts with an excess of asparagine to form compound G with a molecular formula this. Each molecule of compound G has 4 amide group. Asparagine has amide linkage. Asparagine has amide group, which means I need to use more moles of asparagine as compared to propane diol chloride. Okay, so let me remind you. Let me write it down. This is COOH. This is CH. This is NH2. This is CH2. This is CO and OH plus propane dioyl chloride. Okay, that's tough, guys. Cl, CO, CO, Cl. So I'm gonna write another mole of asparagine because examiner was saying we need to use it in excess. CH, NH2, CH2, CO. Oh, my bad. That's not CO. That's not CO. Oh, CONH2. Okay. This is CONH2. That's very, very tricky. It has a lot of working, and that's tricky. By the way, oh my goodness. There is an issue here. Oh my goodness. Oh my goodness. The concept is fine, but I have to rearrange this structure so that you will get the idea what sort of a structure I'm going to form here. See, guys, there is a acyl halide we have, right? Oh my goodness. Oh God. There is a minor mistake also. I forgot to put CH2 here. That's tricky. Very, very tricky. So there is a correction now. And guys, I need to swap these two groups. Okay. So that we can have a reaction between acyl halide and amine. See, acyl halide can react with amine. All right. Acyl halide can only react with amine, which means I need to rearrange this structure so that reaction will take place. Okay. My bad. I didn't. I can write the structure without any issue, but काफी complex हो जाएगा आपके लिए, इसलिए let me write it down again so that you will get the idea what sort of reaction is going to take place. So it's basically CONH2. This is CH2. This is CH. This is CWH, and this is NH2. Now that makes sense. Okay, that makes sense. Let me write this structure again. नहीं, इसको reverse करके लिखना पड़ेगा. This is going to be NH2, then CH, then CWH, then CH2, and then CONH2. Okay, now reaction will occur. H and Cl combine together to give HCl. H and Cl combine together to give HCl. This is amide, this is amide. They are not going to react. So let me write down the structure now. NH2, CO, CH2, CH, CWH. This is NH bonded with carbonyl group. CH2 will remain as it is. CO will remain as it is, bonded with nitrogen. CH and CWH will remain as it is. CH2 will remain as it is. And this amide functional group will remain as it is. Now, examiner was saying that we have 4 amide. This one is first, this one is second, this one is third, and this one is fourth. So ये condition satisfy होगी. Okay, that's the trickiest part because we need to rearrange the molecule so that acyl halide and amine can react together, and also we need to maintain the 4 amide group ka criteria also. So that's tough. Asparagine is hydrolyzed with an excess of hot NaOH. Asparagine is basically this structure. CWH, CH, NH2, that's CH2, and that's CO, NH2. Now, when you treat it with NaOH, obviously this carboxylic acid will turn to salt. This CH will remain as it is. NH2 will remain as it is. NH2 is basically an alkaline group. This is also an alkali. They cannot react together, which is why it will remain as it is. Now this CH2 will remain as it is. Now this is amide. Amide undergoes alkaline hydrolysis. So this amide initially turn into carboxylic acid. And also ammonia gas is given off. But since the medium is alkaline, so this carboxylic acid react together with this NaOH and will turn to salt. So the final product is basically salt. So this is CO, ONA, CH, NH2, this CH2, and this CO, ONA. Okay. So examiner is looking for the organic products only. So I believe you are going to write this one. Okay, that's the only product. Don't write this one because that's an inorganic product. So examiner is looking for this product also. Okay, that's the whole mechanism. That's the whole reaction behind this. And I hope it makes sense to you. Okay, oh my goodness. Oh my goodness. A polymer can form from asparagine as the only monomer. So asparagine contain NH2 and CWH. And we know that both NH2 and CWH react together to give an amide. So I have to rearrange this molecule so that we can make a polymer in which we have 3 monomer residues. Okay, so I'm going to write 3 monomer residues. Oh my goodness. Okay, not an issue. So carboxylic acid, then CH, then CH2, and this is CONH2. Okay. And this is NH2. All right. So I need to make this structure one more time. This structure one more time. Okay. We know that OH and H combine together to give water. OH and H combine together to give water. OH is removed from this side and hydrogen is removed from that side also. So let me write the structure. This is CO, this is CH, CH2, and CONH2 will remain as it is. This NH, nitrogen is bonded with carbonyl. This CH, CH2, CONH2 will remain as it is. This NH bonded with carbonyl group. This CH, CH2, CONH2, and this NH, and bond will continue. Okay. Clearly labeled repeating unit. Oh my goodness, that's the repeating unit. That's the repeating unit, guys. From this to this. This is the repeating unit. From this to this. नोट करो यहां से यहां तक भी repeating unit है. ठीक है. Three monomer residues. These are the three monomer residues. Clearly repeating unit of the polymer. And obviously n moles of water has been lost also. Okay. Let's move on to the next question. Oh, that's the next part. Aspartic acid exists in two optically active form. By the way, aspartic acid is this, and it has this carbon is chiral carbon because this is the first group, this is the second group, this is third, and this whole thing is fourth group. So aspartic acid has chiral carbon atom. So chiral carbon atom means it is optically active compound, and all optically active compound can rotate plane polarized light. As a result, two optically active solutions forms in solution with the same concentration. Draw two similarities and one difference. One difference, similarity is both forms can rotate plane polarized light. With same angle of deflection or with same angle of rotation. Okay, difference. Direction is different. One is clockwise. And one is anti-clockwise. Okay. Give the term used to describe a mixture of equal amount of the two optically active isomers. Equal amount of the mixture is basically racemic mixture. So examiner is looking for the term, so I'm not going to write equimolar mixture. But कुछ लोग लिख सकते हैं equimolar mixture also. But I believe we need to stick to this technical term, racemic mixture, instead of equimolar mixture. मैंने A1 में दोनों बताई थी आपको, बट मुझे लगता है कि रेसिपी मिक्सचर इज मच बेटर आंसर देन द इक्विमोलर मिक्सचर, ओके, बिकॉज इक्विमोलर मिक्सचर तो उन्होंने खुद कह दिया आपको ना, सो डोंट राइट दिस, आई एम रिमूविंग दिस. Let's move on to the next question. That is question number 9. Based on organic chemistry, describe the bonding in benzene. Your answer should include hybridization of the 6 carbon atom. So hybridization of the 6 carbon atom, all 6 carbon atom are sp2 hybridized. Okay. Next, type of bond between carbon atom, sigma bond and pi bond. So between carbon atom, we have sigma and pi bond both. Next is orbitals that overlap to produce the bonds between the carbon atoms. sp2 hybridized sp2 hybridized orbitals gives sigma bond and pi bond is formed through sidewise or lateral overlapping of p orbital. Okay. Now the next is the type of bond between carbon atom and the hydrogen atom. Between carbon and hydrogen, we have sigma bond. Now the next is the orbitals that overlap to produce bonds between carbon atom and hydrogen atom. sp2 hybridized orbital, sp2 hybridized orbitals form sigma bond between carbon and hydrogen. Now this s orbital comes from hydrogen and sp2 comes from carbon atom. Okay. Describe the reagents and conditions for step 1. So step 1 is basically alkylation because alkyl group is attached to the benzene ring. So for alkylation, we need alkyl halide and it must be chloromethane, and the condition is AlCl3, which is acting as a catalyst. Okay. Let's move on to the next page. In step 1, figure 9.1, benzene reacts with this electrophile. Show the mechanism for this reaction, the movement of electron pair using curly arrows, and the structure of the intermediate involved. So the pi bond of benzene interacts with this electrophile, and as a result, we'll get the pi complex. To make a pi complex, we need to attach CH3 from this carbon atom because CH3 attached to this carbon in the product side. Okay. And obviously this carbon also has one hydrogen atom. We need to show that. इस कार्बन को छोड़ के, apart from this carbon, I will use the remaining carbon atoms to make a pi complex, which is represented by positive sign. Okay. Now, bond shifts into the oxygen atom so that we can remove this positive charge. At the same time, hydrogen is removed in the form of hydrogen ion. So you will get product and hydrogen ion. Okay. So you need to show both these arrows. Describe the reagents and conditions required for step 2. Step 2 is what? Step 2 is basically we are introducing NO2 group into the benzene ring, which means we are going to go for nitration. And for nitration, I will use concentrated nitric acid, and concentrated sulfuric acid. And I think temperature is going to be 30 degrees Celsius also. Okay. Identify the reagents required for step 3 in figure 9.1. Compound W is the product of this step. Identify the reagents required for step 3. Step 3 is what? NO2 will remain as it is, but this CH3 is converting into CWH. So this CH3 is converting into CWH, meaning oxidation takes place. And for that oxidation, I'm going to use a strong oxidizing agent like KMNO4, and I'm going to use this oxidizing agent in acidic medium. So I'm going to write H plus sign. Okay. Name compound W. Name compound W. W is basically 4-nitrobenzoic acid. 1, 2, 3, 4, 5, 6. So it's basically 4-nitrobenzoic acid. In the next part, the reagents commonly used for step 4 will not reduce CWH group. Identify the reagents and conditions required for step 4. In step 4, CWH will remain as it is, whereas NO2 is converting into NH2. So to convert, for this conversion, I've told you in the class, we'll be using tin, concentrated HCl. The mixture is a reducing agent and reflux is the condition. Okay. All right. The next part is benzene can also be used as a starting material to make compound Y. Okay. Okay. Describe how the route described in figure 9.1 can be changed to give a compound Y instead of compound X. First of all, this is orthopara directing group and this is meta directing group. This is activating group. This is deactivating group. All right. This is electron donating group. This is electron withdrawing group. For instance, COOH was the first group attached to the benzene ring. So I'm going to use this carbon as the first carbon, second, third, fourth, and this one is fifth, and this one is sixth. So NH2 is technically attached with the meta position, with the deactivating position, that is 3 and 5, right? So I mean COOH is the first group attached to the benzene. अगर मुझे NH2 को फिफ्थ कार्बन एटम पे अटैच करना है, then it means मुझे ऑक्सीडेशन से पहले नाइट्रेशन करनी, मुझे पहले ऑक्सीडेशन करनी पड़ेगी एंड देन नाइट्रेशन करनी पड़ेगी. ओके. In order to attach NH2 on the meta position, first we need to convert alkyl group into carboxylic acid. I mean to say, first we'll go for the oxidation, all right, and then we'll go for the nitration, so that NO2 needs to attach on the meta position, that is 3 and 5. So in step 3, I'm gonna go for oxidation. Yeah. Okay. So over here, first of all, we need to oxidize this compound into CWH. Okay. Let me show you the entire process. This is benzene ring. So because of alkylation, you will get CH3. Instead of nitration, I'll go for oxidation so that I'll get CWH, because CWH is a matter directing group. Now for nitration, NO2 group needs to attach on third or fifth carbon atom. So I'm going to put here, and then we'll go for reduction. My goodness, that's a huge paper, guys. I'm tired. Oh my goodness. This is going to be NH2 and this is going to be CWH. So that was the product examiner has given you here. Okay, I hope it makes sense to you. So explain your answer. Step 1. We will do alkylation. In step 2, we will do oxidation. To get CWH, because it is matter directing or deactivating group. In step 3, we will do nitration. So NO2 is attached to third or fifth carbon. And then we'll do reduction. By the way, we have done orientation in benzene in class in extreme detail, right? डिटेल क्यों जरूरी होती है? अगर मैं आपसे ये कहूं कि भाई सर्टेन अमाउंट ऑफ ग्रुप्स जो हैं वो एक्टिवेटिंग ग्रुप्स हैं, वो बेंजीन की इलेक्ट्रॉनिक डेंसिटी को इंक्रीज करते हैं, रिएक्टिविटी को इंक्रीज करते हैं, तो हर अच्छे बच्चे के जहन में ये क्वेश्चन आता है कि भाई और वो इलेक्ट्रॉन डोनेटिंग ग्रुप्स लगने से ऐसा क्या होता है कि बेंजीन की जो ऑर्थो पैरा पोजीशन है, यानी 246 पोजीशन, वो इलेक्ट्रॉन रिच हो जाती हैं और इलेक्ट्रोफाइल उन्हीं इलेक्ट्रॉन रिच पोजीशन के ऊपर जाता है। तो उसके लिए हमने बहुत डिटेल से आपको एक्सप्लेन किया। इसी तरह से कुछ ग्रुप्स ऐसे होते हैं जो कि बेंजीन को डीएक्टिवेट करते हैं। तो क्वेश्चन इज कि भाई वो क्यों डीएक्टिवेट कर रहे हैं, ऐसा क्या कर रहे हैं वो बेंजीन के साथ जिसकी वजह से वो डीएक्टिवेट होते हैं। सो हमने बहुत डिटेल से आपको ये समझाया कि कोई भी जब डीएक्टिवेटिंग ग्रुप यानी मैटर डायरेक्टिंग ग्रुप अटैच होता है तो वो 246 पोजीशन को डीएक्टिवेट कर देता है। इसलिए इलेक्ट्रोफाइल कभी भी 246 पोजीशन के ऊपर नहीं जाएंगे, इंस्टेड वो 3 और 5 पे जाएंगे, विच इज मैटर पोजीशन। सो जब तक आप ये डिटेल नहीं पढ़ेंगे, आपको आप डिसाइड ही नहीं कर सकते कि वो इलेक्ट्रोफाइल वहां क्यों जा रहा है या उस पोजीशन पे जाके वहां क्यों अटैच हो रहा है। विच इज वाई मैंने वो एरिया काफी डिटेल से आपको एक्सप्लेन किया है। लोगों को लगता है कि वो सिलेबस का हिस्सा नहीं है, बट मुझे लगता है कि वो कॉन्सेप्ट का हिस्सा है, विच इज वाई मैं उस कॉन्सेप्ट को हमेशा पढ़ाता हूं एंड हमेशा पढ़ाऊंगा मैं, ठीक है। और मुझे ये मेरी एक्सपेक्टेशन ये है कि आप लोग उस कॉन्सेप्ट को बिल्कुल भी मिस नहीं करेंगे, बिकॉज दैट इज द कोर कॉन्सेप्ट ऑफ ओरिएंटेशन ऑफ बेंजीन। Thank you guys. That's the end of this paper.